Hello, welcome to my channel. My name is Denny, and in this video we are going to get out our textbooks because we are going to get mathematical all up in here. Yes, your boy Denny, the one who is terrible at math, will teach you a lesson about math, specifically trigonometric identities, reciprocal and quotient identities. Now, in this video or video tutorial or lesson, we will be tackling the reciprocal identities and quotient identities, what they mean and what they are. I will not be doing any actual solving because, God forbid, I teach someone how to do math. I can't even teach myself to memorize my times table, and you expect me to teach someone math? No thanks. You guys are probably better off from learning on your own or from an actual teacher. Anyways, rant about me being bad at math aside, let us move on to the lesson. Now, what are these reciprocal identities and quotient identities? Reciprocal identities are the reciprocals of the 6 main trigonometric functions. The meaning of reciprocal in general is something given, felt, or done in return, but in mathematics, reciprocal means that one quantity or function is related to one another in a way that their product is 1. It is simply the inverse of a value or number. Let us use the number 6 as an example. To get the reciprocal of the number 6, divide 1 to 6. Now you have 1 over 6. For fractions, let us use the example 4 over 9. To get the reciprocal, you need to switch the numerator and denominator. The numerator is the one at the top, and the denominator is the one at the bottom. Switch those two, and boom! You have the reciprocal of 4 over 9, which is 9 over 4. Pretty simple, right? These are basically the reciprocal identities, but with the 6 main trig functions. If you don't recall the 6 main trig functions, I will pop them up on the screen. The 6 main trig functions include sine, cosine, tangent, cotangent, secant, and cosecant. Now, it is important to note that the reciprocal identities are not the same as inverse functions. Inverse trigonometric functions are functions that are the opposite of the 6 main trig functions, in which, for example, arcsine. The arcsine is the inverse of sine, in which instead of it being sine of theta, it is sine raised to -1 theta. Reciprocal identities, however, is where every trigonometric function is the reciprocal of another trigonometric function. To help you get the gist of this, here is a list of the reciprocal identities. I know. It looks like a lot, but it really isn't that difficult. Let's zoom in to get a better picture of this. To help, I have drawn a small right-angled triangle with labels. At the bottom we have A, on the right we have B, and on the slant we have C. The theta is inside of the triangle on the bottom left corner. Now let's start from the top, which is sine equals to cosecant and vice versa. Sine of theta is the opposite of the hypotenuse, which is B over C. And take a look over at the cosecant of theta. The cosecant of theta is basically the reciprocal of that, which is C over B. The sine of theta is 1 over C over B, and vice versa. The cosecant of theta is 1 over B over C. That's our first reciprocal identity. To make it simple, the first reciprocal identity is 1 over sin of theta is equal to cosecant of theta, while 1 over cosecant of theta is equals to sine of theta. Now you may be wondering, but how? Why did you divide 1 over the fraction? Simple. Dividing 1 by the fraction is going to result in the reciprocal of that fraction. So let's say again, 4 over 9. You divide 1 by 4 over 9, it will be turned into 9 over 4. This pattern of relationship is similar to the others, and it continues with cosine and secant, and tangent and cotangent. For the secant and cosine, notice how for the cosine of theta it is equal to A over C, and that the secant is the reciprocal of that, which is C over A. The same rule of thumb of dividing 1 by the fraction applies here. The secant of theta is 1 over a over c and vice versa. This will then give you the other reciprocal identities like 1 over cosine of theta is equal to secant of theta and 1 over secant of theta is equal to cosine of theta. The same rule goes for tangent and cotangent. Just imagine that these pairs are couples and that they all have one thing in common. The sine of theta and the cosecant of theta are the high school sweethearts, the ones who are popular and hot. Sine is the jock and cosecant is the cheerleader. While the cosine and secant are the two emo lovers who love My Chemical Romance and edgy humor. And lastly, tangent and cotangent are the artsy couple that love painting and creativity. Now that we have discussed the reciprocal identities, let's now move on to the quotient identities. Quotient identities, as the name says, involve the process of dividing trigonometric functions with each other. To get a better view, let us zoom in. For now, let us look at the relationship between these six by dividing them. So here, let's take b over c sine of theta and divide it by a over c, which is cosine of theta. So if we take b over c and divided that by a over c, it'll turn into b over c times c over a. Because when you are dividing fractions, you need to multiply the first fraction to the reciprocal of the second fraction. C will be cancelled and we will be left with b over a. Now, if you take a look at this here, b over a is actually tangent of theta. So, in short, sine of theta, which is b over c, over cosine of theta, which is a over c, is equal to tangent of theta, which is b over a. Now, this is our first quotient identity. We can do something similar to get the second quotient identity, but this time with the cosecant of theta and the secant of theta. But it's too complicated, so let's not do any of that. But instead, let us use our big little noggins up in this brain right here. So you know that cotangent is the reciprocal of tangent, right? The cotangent is equal to 1 over tangent of theta. Well, since we found the tangent is equal to sine of theta over cosine of theta, we can take the reciprocal of tangent and it will be cotangent. So since tangent is sine of theta over cosine of theta and cotangent is 1 over tangent of theta, cotangent will be cosine of theta over sine over theta. Mind blown. Okay, so we have all of them now. The best part about this whole reciprocal and quotient identity is that if you have two of them, you can basically get the complete set of trigonometric functions. It's like a buy one, take one deal. Since you have bought a pack of gum, you get another one for free. What I mean by that is if you have, let's say, sine of theta and cosine of theta, if you have those two, you can pretty much get the other trigonometric identities. With sine, you can get cosecant, and with cosine, you can get secant. And if you have sine and cosine, you can divide those two and then get tangent, which then you can do the opposite of that to get cotangent. To conclude our lesson for today, reciprocal identities are the reciprocals of the 6 main trigonometric identities. One of the examples of this is how sine of theta is the reciprocal of cosecant, and where cosecant of theta is equal to 1 over sine over theta and vice versa. We learned that this applies to the remainder of the 6 functions like cotangent and tangent, and cosine and secant. Quotient identities involve the division between all the trigonometric functions to get the 2 quotient identities. We learned here that to get tangent, we need to divide sine of theta and cosine of theta. And since cotangent is equal to 1 over tangent, we can say cotangent is the cosine of theta over sine of theta. Hope this video helped some of you, and as some of you may know, we didn't show any real solving because frankly, we're out of time and I'm not good at it. But I hope my explanation wasn't too muddy or confusing. If it was, I'll put links to my sources down below, or maybe in the OneDrive that I will be providing for my teachers to see. And it will also be on the end card, so yeah, go check that out. And excuse me. Yeah, thank you so much for listening. This has been fun, and I hope you learned something. I certainly have learned something. Thank you for watching, and have a great day!